Hello everybody and welcome to this tutorial where we will be talking about modeling this trailer. The main focus of this tutorial is to introduce the so-called master model technique alongside with some tips and tricks which will help in improving our productivity when it comes to modeling such a model. Along the way I will be mentioning some technical details that hopefully will be helpful for some of you. With that being said, let's get started with creating a new part file. And make sure to set the units to mmgs. Usually before starting the modeling process, I prefer to decide which is the best plane to start at. So if I have a lock here at the original model, I would love to see like this part to be on the side view. It's not a big deal, but it makes your model looks better. For that reason, I will start with the right plane, because I will start with modeling this main beam here. So I will pick the right, and I have some already set information I will be sharing with you now. The overall length of this beam is 10 meters. For that reason, I will set this line to 10, and I will turn it into a construction geometry. The length of this side overall will be 600. And now I can keep going with drawing the overall profile to look something like this. Now I need this line to be horizontal, and I need this length to be 2500, and I need this to be 5500. Before exiting this sketch, if we have a look back here, we have some kind of end plates here and here. And it's very important to take into account for these plates. To do so, I will simply offset this line by 10 millimeters to this side, and I will offset the other one. I reverse the direction, 10 millimeters, and it will be better if we just change this into a construction geometry. Once done with this, exit the sketch and hit to extrude. Now, as you can see, we have the thin feature activated already because of the offset we did here, and since we don't have one closed loop sketch. Now, let's hit select contours, clear this, and simply select the enclosed area between these lines, and then turn off thin feature. Now I want to make sure this is a mid plane. Also from menu here, I need to select offset, and I want this to be 650 millimeters. When everything is done, hit OK, and as you can see now, we have it. The right plane is right in the middle of the part file, and here we have this offset. Now, let's say you have a stock of sheets which is 3 meters by 2 meters. So you need to make sure that the maximum length of any part or body of this beam won't exceed 3 meters. Now, here you have many options to do so. The one I prefer is to use the split tool. Now, to do so, I can start here or on the mid or on the right plane, but I will create a plane between these two faces here, because this will be handy later. We will talk about it in some detail. So I'll start a sketch here, and simply I'll draw these lines. First, I need to make sure they are parallel, and I need to make sure that these 2 points are horizontal. And I want to make sure that they lie on this edge here. after that, I need to make sure that this angle here is 45. Now, at this point, you should think in terms of welding. And before doing so, let's make these equal. So instead of having a vertical weld bead here, it's better to have it inclined with some angle, and that will contribute in a good way to reduce the shear force that resulting from having a vertical weld bead. So having these two parts joined with this angle will enhance the performance in terms of shear force. So now I want to make this distance not more than 3000. Now this time you should be careful. I want to make this point coincident with this edge here, and instead of selecting this point with this one to make it 3000, I should select this one and this one, because the maximum is at 3000. Now I will hit equal, and I will just simply select this dimension here. Now let's do the same again. Now for sure there are many ways to do this. And now the same story. From this point up to this one, hit equal, and let's set it to 3000, then hit OK. Now one last thing. Now we need to make sure that this distance from this point up to this line here is less than 3000. I will pick a center line, and until it snaps here. This will overdefine the sketch, but don't worry about it. Now we are sure that this length is less than 3000. We are in good shape. Now exit the sketch and make sure to access the commands here and hit split. Since we only have one body, SolidWorks won't ask you to select the bodies. It assumes that you want to trim this one. So for the trim tool, it will be the sketch. It's already selected. If not, you can show the sketches from here. Make sure they are shown and simply select it. Otherwise, you just head to the tree and select sketch 2. And for the body, just select this geometry, then cut part. Now SolidWorks gives you a preview of what will be done. So we have one body, 2, 3, 4, and you have the option to keep or to remove them. For sure at this point we want all the bodies to be kept. For that reason we will select all, and now you can assign names to these bodies, but I will leave that for later. Now hit OK, and if you have a look here, we have solid bodies and we have 4 different bodies. Now the next step is to create the flange here. To do so, at this point I will select the plain one, and that's why I created it in the first place. Now you know that you are in the middle of this sheet here, and you don't really need to worry about the distances, so it makes your life easier. So select plain one and draw a line from this point up to this point. Exit the sketch, then hit extrude, and now make sure to turn off merge result because I want to create independent bodies. Now mid plane, and this should be 200 millimeters. Now make sure it doesn't interfere with this web here, and the thickness is 10 millimeters. We are okay, then hit OK. Now the same story, I want to split this part as well. To do so, simply select this face, and I want bodies each of a maximum length of 3000 millimeters. So this should be 3000. Now you can repeat the same thing, but at this point Okay, let's do the same thing here. For sure you can take advantage of the option pattern, but I prefer to do it this way. Or you can take advantage of offset as well. It works perfect in this case. Now, it will be way better to clean up this sketch by making these 3 lines equal, by, for example, setting these to be coincident with this edge here, and doing the same here. Now we will hit split once again, and make sure not to confuse it with this split. This is a split line, and we need this split. Now, as you can see, we have some kind of difference here, and let's talk about it. First of all, the trimming tool will be the sketch we already created, which is sketch 4. Now, since we have a multi-body part, it asks you which bodies are you interested in splitting. For this reason, you can select all bodies or selected bodies. In our case, we will select only the flange, then cut bodies. And here it gives you a list of 1, 2, 3, 4 bodies. So, since we want to keep all of them, we select everything, then hit OK. And now, as you can see, we have the upper flange. Now, when it comes to the lower flange, it's a bit different, because here it involves some kind of sheet metal work. Because I guess we will have to do some kind of bending here. For sure, you have the option to make this an independent sheet, and this is an independent one, and weld them, but let's see how this can be done using the sheet metal features. To do so, I will go back to the plane I created, which is plane 1, and hit a sketch. And now simply I will start with sketching a line from this point up to this one, then up to this one, then up to this one, and make sure that your sketch is fully defined. Once you're done with this, now hit to the sheet metal tab and base flange, and I want this to be also 200. I want it to be mid-plane. Make sure the thickness is 10 millimeters. For the bend radius, I will set it to 4. And for the K factor is 0.5. If you're not familiar with the concept of the K factor, I think in the description of this video I will list a link of a video that describes it in a very good way. So the last thing to check is not having any kind of interference. And here, as you can see, we have interference. To solve this problem, simply we reverse the direction of the thickness. Now we don't have it. Now hit OK. Now, if you want to, let's say, flatten this part and measure the length, we are talking about like 10,000. So we need to split it as well. I will not split it looking at it from this plane here or from this direction. I will do it looking at it from this direction. And the advantage of that is that we will have some kind of control over the length of the bends here. Now we will see. Before doing so, I will just select this body, right click and isolate. Then I will select the right plane and I will start a sketch there. So I'll draw a line and I will make sure that this distance here is 3000. Now this part is a bit tricky. We need to check something. We need to see if this distance before the bend or after the bend 3000, and basically it's after the bend. So let's say this is 3000, and that involves having this bend here. But due to that we have an angle here, we already know that this length will be more than 3000, and we don't want to exceed it, because imagine if you flatten this part here, the length will be more than 3000. To solve this problem, we simply start with a sketch and a line here, and another one here, and another one here. Now select measure and pick the line you already sketched here, and here it tells you that the length is this value. Now zoom in, select this line as well, the total length has increased. Also select this one, and as you can see, this number here is 2000 something. So maybe you will need to write it down or to do a symbol like calculation. Let's say 3000 minus this number. The result of this is 344.17. In other words, this length should be increased by 344.17. Now to do so, simply select dimension, select this line, and after you have this value here, click anywhere in this field, then hit plus, and now let's do 344.17. Then hit OK. Now what I really know is that the end of this line should be at this point. It shouldn't be 3000 horizontally. So I will delete this dimension, and I will set this point with this line to be coincident. Maybe in the end we will need to do some kind of modification due to the nature of the sheet metal behavior. We are talking about the stretch that happens to the material when performing bending, but we will treat it once we are done with this split operation. Now the same story goes here again. Let's start with a line. So now at this point this length is 1000. Okay, we need to expand this a little bit, and now let's hit to measure, select this edge or the line we sketched to be more specific, this one and this one, and now the overall length is 1688. Now let's repeat the same procedure. Logically we are talking about 3000, which is the overall length of the sheet we have, minus 1688.6. Hit equal, and that means we should increase the length of this segment by 1311. Now to do so, hit Smart Dimension and click anywhere in the field, then plus 1311.4. Now I will pick a midpoint line and I will draw a line here. I just want to draw your attention to that these lines must be construction lines, because we will use these lines to split this body, so we don't want SolidWorks to confuse it with these ones. That's why they should be only horizontal. That's why they should be construction geometry. Now to double check our work, let's go back to measure and select this line and this one and this one, and here the total length is 3000. That's fine. Now as we did before, we just need to check the length of the remaining part of the split. And this is only 1000, which is below the 3000. We are in good shape. So at this point, let's do these 3 points to be horizontal. And these 3 to be horizontal as well. And we just maybe, to have a fully defined sketch, let's give it a length, let's say 1000. Okay, once you're done with these, Make sure that the sketch is selected, hit split again, and this time for the bodies, select this one, then cut bodies. And again, we have a list of bodies to be cut, select all of them, then hit OK. Now, let's have a look at the model tree here. We are talking about like sheet metal parts. So, we need to check our work. For this reason, for this length is a 3000, which is fair enough. Now, the critical part is this one, which is this part. Now, I will exit the isolate, and I will isolate it by itself. This is not important, but just to see it in a better way. Now, I will select this face and select flatten. And then I will need to measure the overall length. So, it's a bit less than 3000, which is fair in this case. Also, we need to check the other part which has a bend, which is this one. And I will isolate it, select it, and flatten it. And then measure, the edge. It's 3000 and it has around 0.75 millimeters extra. So what we really need to do is that we need to decrease this one by 0.75 and we need to increase the other one by 0.75. To solve this problem, we only need to deal with the sketch responsible for the split. So let's edit this sketch here. And I want to reduce this length minus 0.75. And let's see what happens. Now I flatten it again. So this is fair at this point. Once this is fine, we need to check the other one. It's a 3000 as well. So now in terms of sheet metal, we are doing fine. Then we need to do the end plates, which simply select this face here. And let's pick a corner rectangle and let's snap to this point up to this point. And now this should be only 10 millimeters. Make sure to remove the merge result and set this to 10. And we need to do the same here. And we need to extrude this to 10 millimeters. So this is how we create this main beam here.